Okay, so 5G phone is like you have 3, 4 phones put together. So when you latch to 5G network, the capability of 5G can be utilized. If you latch to 4G or 3G network, whatever 3G and 2G have latency, those can be availed. It's not that having a 5G phone will allow you to have better latency even in 4G and 3G phone. Did I answer your question or you had something else?
Sir, still I'm having doubt because
Okay,
for the 2G and 3G, that data rate speed was not that much of 5G, no. So because of
correct.
that, for getting the total amount of data transfer, the delay will be more. So it can be viewed as a latency in receiving that data then in that
Correct.
situation.
Correct. So, I mean, all the benefit of 5G will be there when you are in a 5G network. You are being served by a 5G network. If you are, although you may have a 5G device, but if you are being served by 4G, 3G, 2G network, then you will not get benefit of 5G network, right?
Okay, sir. Thank you, sir.
Right. Okay. Okay. So, let's start today's session. So yesterday, we could complete 5G core network part 3. So I'll start with part 4, and in case any of you have any question or doubt on part 3, I can answer. Okay, let me share my screen. Please confirm if my slide is visible to all of you.
Yes, sir.
Yes,
Visible.
sir. Slides are visible.
Yes, sir. Yes, sir.
Thank you. So today I'll try to cover some more aspects of 5G core architecture, and this is part 4. And in this, I'll be covering two aspects. One, we call it CUPS architecture, which is nothing but migration of 4G core to 5G core. And what are different options of deployment of a 5G network? Because uh, there are many ways an operator can uh, migrate from 4G to 5G, and which option is best for an operator can decide. Okay, so this is a typical 4G network diagram. And we had seen this, and this picture I have taken from empirical.com. This you can use for other resources of 5G also. So if you look at 4G network function, you have MME. MME is Mobility Management Entity, which takes care of mobility aspects and also the session management part along with SGW and PGW. And this is also an interface for user equipment to talk to the control network for authentication and authorization. So this is a control plane network function. And then we have HSS, home subscriber server. It is similar to our HLR in 2G network or 3G network. The BTS in 4G is called eNode B. BTS in 4G is called eNode B. And the user data path is like from user equipment to eNode B to serving gateway and to PDN gateway, and finally to a packet data network, which can be internet or which can be any other service. What we see here is, although this is part of user plane, but SGW and PGW is also involved in session management, which is kind of a control plane function. So that means in typical 4G network, we do not have a clear segregation of user plane and control plane because in user plane, SGW and PGW are also doing some control plane activity like session management. Whereas the concept of 5G is that we will have a separate user plane and separate control plane so that we can evolve both the plane separately as per the requirement, and I can put user plane near to the user and also deploy the edge network, uh, multi-edge computing kind of a network. So to support that 3GPP in its release 14, please remember this is the release 14. That was the transition release to 5G because release 15 was for 5G. So here they had come out with architecture of 4G which is called CUPS. C is control plane, UP is user plane, S is separation. Control plane, user plane separation architecture of 4G. So what they try to do is like, as I said that SGW serving gateway uh, does control plane part and also the user plane part. So SGW they have broken into two network function. SGWC, C stands for control plane, and SGWU for user plane. So they have completely now segregated user plane part of SGW and control plane part of SGW. Similarly, PDN gateway or P gateway also they have divided into two part, control plane part and user plane part. So you have now in 4G also we have separated the user plane part and control plane parts. And now the data will flow from user equipment to Z node B, ZNB to E node B we call it, E node B to serving gateway to PDN gateway, and then it will connect to any of the packet data network. So this becomes now a completely segregated user plane even in 4G if you follow the release 14 CUPS architecture, CUES architectures. And then how you can deploy is like now you can create a NFV infrastructure, network function virtualization infrastructure. And on top of NFV, you can deploy these elements as a VNF, virtual network function. That is some sort of app. So MME and control plane part of SGW and control plane part of PGW. So what we have done here is like all the control plane of 4G, we are able to deploy on a centralized location on a NFV infrastructure. And the user plane part of SGW and PGW can now be located near to the user along with the E node B. So you'll have a E node B in cities, multiple E node B. So in that city itself, you can have instances of SGWU and PGWU, and then you can connect PDN here itself in every city if you want. So this is becoming to similar architecture as 5G. So 4G architecture in release 14 has been tried to be followed all the concepts of 5G itself. So that's what operators have tried and done across the globe, that they have uh, like evolved their 4G core to release 14, implemented CUPS architecture, and then they are migrating to 5G. So suppose you want to migrate to 5G, or also you want to have a standalone 5G network together. So what operators can now do that on the same NFV infrastructure where 4G elements are hosted like MME, SDWC, PGWC. So on the same NFV infrastructures, operator can actually deploy 5G network functions. So here it is shown that AMF and SMF are now deployed along with the 4G core. And onto the user plane side, now you have SGWU and PGWU, and you can also deploy UPF for your 5G part of the base station. So now you have kind of a combined 4G and 5G core, and in the field you have a 5G and 4G network both, and in every city or every geography you are having decoupled or separated user plane part, UPF of 5G and SGW PGW of 4G. So in slightly detail how 4G and 5G is being mapped. So what you see is like in the legacy 4G network, you have all the network function like MME, HSS, PCRF, PGW, SGW, and PGW, and they are connected on a reference point uh, like GX, S6A. These are the different interfaces in a 4G network. And here you can see that SGW and PGW is handling the user plane part of the traffic and also some control plane part of the traffic. But after the CUPS architecture, that is release 14, so they have separated PGW into two part as I discussed, and SGW in two part. So dot dot is all control signaling, and solid line which you see here is the user plane part. And then how it is mapped kind of. So AUSF in 4G is kind of sorry, AUSF in 5G, AUSF plus UDM in 5G is akin to HSS and AAA of 4G. Similarly, PCF of 5G is akin to PCRF of 4G. Similarly, the session management function SMF of 5G have taken over some function of MME, some function of SGW, CP part of SGW and PGW. And then access and mobility function AMF of 5G has taken over some function of MME. And onto the user plane part, UPF is the 5G network and SGW, PGW user plane part is of 4G network. So this is the kind of mapping we can understand. Okay, so with this, so
Sir.
yeah, please.
Excuse me, sir.
Yes,
Can you
please.
please say what is EPC in the previous slide?
So EPC is 4G core. We call it Evolved Packet Core. 4G core is also known as Evolved Packet Core EPC. It's a name given because it was for the first time that the network is a pure data network. So they called it Evolved Packet Core. In 3GPP standards, this is named as EPC. 4G core is named as EPC. Is that okay?
Yes, sir.
Okay. Any more question so that I complete that and go to the next part of the session? Okay. So next part of the session is different deployment options which operator can use. Deployment of 5G, how one can migrate from 4G to 5G, what are different options provided in the standard. So as you recall that we have talked about non-standalone deployment. So non-standalone deployment means that I have a 4G network, that is 4G core and 4G radio, and I am installing additional 5G radio onto the same network. That means I do not have 5G core, I only have 5G radio. So this is called NSA mode of deployment. So in this case, what happens is the 4G radio, that is E node B, we call it, works as a master radio, and the 5G radio network which we are deploying is kind of a slave to the 4G E node B. And how traffic flows is like a device. Suppose you have a 5G device. This is a 5G device supporting NSA mode of deployment. So primarily it connects to the 4G network. Initially it connects to the 4G network. And then this E node B will know that the device is 5G, and then it will ask, that means E node B will ask this 5G device to use this signal coming from the 5G BTS nearby. So your device can connect to 4G, your device can connect to 5G both. So that means 4G radio network has full control over 5G, deciding when the device can use both 4G and 5G radio simultaneously. And this 5G radio is mainly responsible for handling user data of the device on 5G, of course, under the control of this 4G network. So what benefit we get is that in this coverage area of this BTSs, user are able to have more speed or 5G speeds. That means we are able to realize enhanced mobile broadband feature. But in this architecture, we will not be able to realize URLLC or MMTC features, that is latency sensitive applications, and sensor IoT kind of a devices will not be working. So this is NSA mode of deployment. An operator can follow. Worldwide, most operators are following this. In India, Airtel follows this. Jio has a standalone network. So how internet traffic can flow in a NSA network? So just you can see that there are two-way uh, one can connect. If the device is in 5G coverage, suppose device is here, so the data flow will be through the 5G radio network. So of course, this 5G, this one is connected to the 4G on XN interface. So backend data goes like this. Backend data goes like this. But for UV, this 5G radio is being served. If your UV is in 4G area, pure 4G area, then 4G will handle. If your UV is in an area where you both have 4G signal and 5G signal, then web traffic can be handled by both 4G and 5G. So aggregated speed would be much better. Now, how voice call be handled in a NSA environment? As we know that pure 5G network will not have voice capability initially. So initial voice traffic has to be handled by uh, voice over LT, VoLT. So for voice traffic, so whether uh, you are in 4G area or you are in 5G area, it will always be handled by voice over LT on 4G network and not by 5G. So 5G will not be supporting voice network initially. Once, I mean, we have a SA mode of 5G and we also have a voice over NR, VoNR ready. It can handle the voice also. But in the NSA environment, voice will be handled by the 4G network itself. So, so we have discussed of one option of deployment. So there are 6 options of deployment. Just see option 1, 2, 3, 4, 5, and option 7. There is no option 6 available. So basically, as we saw in the NSA mode of deployment, that one of the radio is a master and the second radio is a slave. So in each of these deployment option, one of the radio will be master and one of the radio will be slave. So let's talk about option 1. Option 1 is nothing but a pure 4G network where core is evolved packet core and radio is LTE. And I don't have a second type of radio access technology. So 3GPP calls it LTE, and this is a kind of a release 8 of 3GPP. Now comes option 2. So option 2 is a pure 5G network. This one is the option 2. Option 2 is a pure 5G network where 5G core is the core, new radio or G Node P is the radio. There is no other type of radio. So this is called NR, new radio. So the option 1 is standalone. This is standalone 4G and this is standalone 5G, right? There is one more standalone, which is option 5. There is one more standalone, which is option 5. Here, what we are talking about is core is 5G core, but radio is LT radio, enhanced version of LT radio. So this is called ELT. So this is also one type of standalone because I have only one radio. Now, so 3 options are standalone option and rest of the 3 options are non-standalone. So starting from option 3, this one, this is NSA. Here 4G core is the core and LT is the master radio and 5G radio NR is the slave radio. The one we just discussed, NSA mode of deployment, was option 3. Please remember that option 3 is very popular and that's what Airtel and other operators have actually gone for, that in their existing LT network, they have just added new radio BTSs as a slave BTSs. This is, I mean, please remember this, the name given for option 3 is ENDC. E is like E is E Ultra. E Ultra is the name of 4G radio and N is the new radio. D is the dual, C is the connectivity. E Ultra, new radio, dual connectivity. Please remember the nomenclature. The next NSA option is option 4. Next NSA option is option 4, where 5G core is the radio. New radio is your master radio. An enhanced version of LT is your slave radio. So that's why we call it NEDC. What is NEDC? N is for new radio. E is for E Ultra, that is 4G. Dual connectivity, NEDC. Just remember when you say ENDC, E Ultra, new radio, dual connectivity. The first radio name is master and second radio name is slave in this. Now the option 7, last option is option 7, where I have 5G core as a core, ELT, enhanced version of LT as a master, and new radio as a slave. And this is called NGENDC. Why NG? This is next generation E Ultra. This is the name for ELT. And then you have a new radio, dual connectivity. Okay. And when they came into picture, like so in which release all these came is written here for your information. So this came, these all options were talked about during the release 15 itself. Give me a moment. Okay, so let's look at all these options in slightly detail.
Sir, 1 minute, sir. I have one.
Yeah, please go ahead.
In previous slide, E, can you write what is that exactly? We are unable to get ENDC. Now, E, can you write there on screen something what you are mentioning? We are not getting clearly. E.
Just see, I have written.
Yeah, please.
So E is E Ultra. So universal terrestrial radio access network, right?
It's an acronym for some.
Yeah.
Okay, right.
4G. This is 4G radio. Okay. You can Google it.
Sir.
Okay.
Okay, sir. Okay, done.
Right.
Thank you.
Right. Okay. Okay. So pictorially, let's see these options. This will make you more understandable. So this top row is all the standalone option which I talked about. Whatever the standalone, option 1, option 2, and option 5. So this is option 1. Option 1 means I have 4G BTS and 4G core. Option 2 is also standalone where I have G node B, that is 5G radio and 5G core. And option 5 is I have an enhanced version of LT called next generation E node B connected to 5G core. I don't have dual radio. So these all are SA mode of deployment. In the NSA mode, that is non-standalone, or you can also call it a dual connectivity mode. So first is the option 3. Option 3 is what? G node B is the master. Sorry, I'm sorry. That is E node B is master. This is the master BTS and this is the slave BTS. So this is called option 3. In option 4, G node B is master and we have a 5G core here, and E node B is a slave. So that's why we call it NE. NE is new radio, the master one. E is E ultra and dual connectivity. And then we have option 7 where you have 5G core. And then master radio is evolved version of LTE, that is NG-LTE. This is the master and this one is the slave. So these are various deployment option. But if you deploy any of the NSA mode, ultimately you have to evolve to the standalone mode. So what operator has, so if you want to remember this diagram, this is say option 1, option 2, then come below option 3, option 4, and then you have option 5 and option 7 if you want to remember it. So 1, 2, 3, 4, 5, 6, 7. Option 6 is not there. Okay, so let's look at these options. So operators have actually deployed this option, right? So what they will slowly do that over a period of time, they would try to move to option 1, right? Option 1. So what they will do once they are able to deploy a 5G core, they will connect 5G core and 4G core on N26 interface we had talked about. And then they will now parent this 5G core, 5G radio with the 5G core. So ultimately they will become option 2 standalone 5G along with standalone 4G. That's the strategy most operators are following. Somebody can follow other methods of deployment. So let's look at option 1. So option 1, as I said, that it's a pure LT network. It's pure LT network. So I don't need to explain it. Option 2 is a pure 5G network. Pure 5G network. So when you have a pure 5G network or greenfield 5G deployment, which Jio has done in our country, so you can take benefit of all three usage scenario: EMBB, MMTC, and URLLC. So all the three features are available for use. So that is option 2. And most operators, the other standalone option as I discussed is you have a 5G core, but radio is LTE. So in this case also, you may not have all the EMBB, URLLC, and MMTC feature because the BTS is not there of 5G, it is 4G BTS. Now in a non-standalone way, which is very popular. So here what happens, as I discussed that here, E node B is master, core is 4G core, right? So how data traffic is going? So if you have a pure option 3, so what will happen? Control plane and user plane of G node B is going through E node B towards the core. So this is the path followed for control plane as well as user plane traffic coming from the G node B. But there is another option called option 3A, where the user plane traffic can directly go to the core. Now the G node B can have a direct connectivity with 4G core, and at least the user control plane will still be handled by E node B, and through E node B it will going, but the user plane part of the traffic can go directly to the evolved packet core. So that is called option 3. There is a possibility that I can have both options. So that is called option 3x, option 3 and 3a. So this is option 3 which operators have deployed. And then option, yeah, any question? Yeah.
In which case option 3 and option 3 and option 3x happen?
Yeah. What's your question? Can you repeat?
So in which case option 3 is happen means there is no connectivity.
Okay.
G and B.
Okay. So yeah. So suppose from G node, so there are two aspects of it. To support S1U interface from G node B. So G node B S1U interface is different than S1 interface coming from E node B. That means I have to upgrade my core, at least the interface part, to support G node B. So once my EPC is ready and upgraded to handle user plane traffic coming from G node B, because it has different method of talking to core, then this is possible. If that is not becoming possible, then your E node B is sort of translating the control plane traffic and user plane traffic. So the traffic goes to E node B, and from E node B it goes to the core. So initially they will deploy option 3. Once their EPC is ready and also there is a connectivity available, they can go to option 3. And they can also look at option 3x, that some part of the data can go on S1U, some part of the data can go on S1U of the 4G. Did I answer your question?
Yes.
Okay, great. Okay, this is option 7, which is called, as we said, engine. So new radio, enhanced version of 4G, that is NGEN is master here, and this is slave. But 5G core is the core. Here I don't have a 4G core. So this is akin to that some operator having a 4G network, they have just enhanced their core to 5G core and also upgraded their 4G BTSs and made them enhanced version of E node B. So they have 5G core and 4G BTS, and then keep on adding new G node B BTS as a slave BTS onto the network. So this is the option 7, which we call it NSA LT assisted, because E node B is the master. So here also same thing. Initially traffic will flow like this from G node B to E node B and to the 5G core, both control plane and user plane. But later on, it can be NGU going directly here once your connectivity is in place. And then you can have a combined option as option 7x.
Excuse me, sir.
Yeah, please.
Sir, here is it possible to experience all those 3 use cases
So, right. So since you are able to connect the 4G control plane through the 5G control plane through the LT itself. So we may not be able to realize all the features. So we'll be able to realize only EMBB feature in this scenario. But later on, you can make this G node B as a master once more number of G node Bs are into the network, and you can make so initially what will happen, lakhs of BTS will be 4G, only few BTS will be G node B. So initially they will be trying to use the EMBB feature. Later on they can make it G node B as master and 4G network as the slave network. That's the possibility. And in that case, then they can realize all EMBB, URLLC and MMTC feature. But with this NSA architecture, they can only enjoy EMBB feature.
Okay, sir. Thank you.
Okay. So now the last option as option 4. So which is here master is a new radio. In this case, 5G core, the one I said no earlier, that if you have this architecture, you can migrate to this architecture. Uh, uh, Once you have more number of G node B BTS, here G node B is the master and 5G is the core. So in this case, what is happening is 4G traffic is going through 5G. It has become reverse in this. Uh, and in 4A option, you can have also an interface towards core for user traffic. Control plane will always go through the G node B connectivity. So this is option 4. So we have discussed all these SA and NSA option. Yes, please go
Can I
ahead.
have a question, sir?
Why not? Yes.
So actually, when there is a change in 4G to, I mean, when it uses both, what about the packet formatting? Packet formatting is different, no, sir? How it is handled?
So depending upon which option we are talking about, so basically if so sort of suppose whichever BTS is the master one, okay, uh, so it converts the packets into that format. We can consider that, right?
Okay.
And that's why that is in place. That's why we
So-
have to enhance the master BTS to like I mean support the traffic coming on XNC and XNU and convert into the format which core is understanding at that
Okay.
point of time.
Okay. So it depends
Okay.
on the master BTS.
Yeah.
Okay. Thank you.
So, but mostly option 3 is in like option 3 is the option which all operators have actually followed. Rest of the option I have not seen any operator following. Option 3 or standalone straight. So these are the two options which operators have gone for. So as of now, about 40 operators are on this option, and I think there are 800 operators, so almost and 300 operators have launched 5G 300 plus. So almost 260, 270 operators are on NSA mode, option 3, and only 40 plus operators are on SA mode as on today. But ultimately, everyone will move towards the SA mode.
Thank you, sir.
So this part I have completed. I have since this was left out from yesterday, I have a session related to the quality of service, which I will try to complete today. So maybe I can take more questions if there are.
Is there any difference in performance wise between SA and non-SA, or both the same, or which one is the advantage?
No, SA has got more benefit because then you'll be able to realize all features of 5G. In case, so there is a history behind it. Let me tell you the history that will make you understand better. When 3GPP was trying to make standards of 5G as part of release 15, so every operator was in hurry to migrate to 5G. Everyone want to be first mover advantage in 5G. So what they talked about is that can there be a solution wherein I can use 4G core, 4G network because every operator will have, and then I can connect 5G BTSs. So that option was agreed, and they had a early drop of release 15. They had an early drop. So release 15 was done in 3 parts. Otherwise, releases are done in a single part. So release 15 was done in 3 parts. The first drop of release 15 was like to support NSA mode of deployment, where if an operator is having 4G network, they can just put a 5G BTS, connect to the core 4G core towards the 4G BTSs nearby, and then they can enjoy a higher speed. So that was the main aim of NSA mode. And since that was the initial option and easiest option for operator to do, cost effective option for operators, so all operators followed that.
Yes, sir. Thank you.
Did I answer your question, or you have any supplementary question?
Performance wise, both are same, or is there any difference?
No. So 5G performance will be much better compared to 4G performance.
I'm asking between SA and non non-SA.
That's what I'm saying. The SA performance will always be better compared to NSA. When I say NSA, it is basically a 4G network and you have deployed some number of 5G B2S in between. Nothing more.
Thank you.
Yeah. Okay, so let me stop recording so that there'll be a new session and then I start the recording again.